First up, let's turn this into a matrix. So we've got 2, 5, -3, 3, -1, and 4. Okay, our first goal here is to change this 2 into a 1. So in order to do that, we're going to multiply 1/2 times row 1. Okay, I'm going to copy row 2 as I go. Okay, and to multiply that, so we've got 1/2 times 2, 5, -3. So this is 1, 5/2, and -3/2. So fill in 1, 5/2, -3/2. Okay, next up, we want to change this number, this 3 below it, into a 0. And remember, you always go in order. 1's first, 0's second. Okay? So in order to do that, remember, you use the 1 we just made. We temporarily will change it, not permanently. So we're going to say -3 row 1 plus row 2, right? The opposite times that top row. So 1, 5/2, -3/2. Okay, and then the multiplication down here, we've got -3 times row 1, so that's 1, 5/2, -3/2. So this becomes -3, -15/2, and +9/2. Okay, to that we're going to add 3, -1, and 4. Okay. So when we do that, these cancel, right? So we're left with a 0. And then over here, we can write this as -2/2, right? So -15/2, -2/2 gives us -17/2. And then over here, 4 can be written as 8/2 plus 9/2 is 17/2. Let's fill those in. 0, 17/2, 17/2, okay? Perfect example of sometimes it gets a little uglier before it cleans up. Okay. So next up, we go to the next column over, so we're in column 2 now. And remember, we want to follow that pattern of 1s down the diagonal, right? So our next job is to turn this into a 1, okay? So just like before, we use the reciprocal value. So we're going to multiply that times 2/17. Okay? So 1, 5/2, and -3/2. And really, so far, nothing is different from Gaussian elimination, right? So far, everything is the same. So we've got 2/17 times 0, 17/2, and 17/2. So when we multiply, we end up with 0, 1, 1. Okay, and this is great news because now we have 1s down our diagonal, right? We would be done if we were doing Gaussian elimination. For Gauss-Jordan, we have to go that one extra step, and we want to turn that 5/2, this lets me change it. We want to turn that 5/2 into a 1. So let's do that just before we're done. Remember, you use the 1 from its column. So we're going to say negative, so it's opposite, 5/2, row 2 plus row 1. Remember, that last row you write is the one that you're trying to change. Okay? So 0, 1, and 1. So if we multiply all that out, -5/2 times, I'm looking at row 2 right now. So 0, 1, and 1, big parenthesis, right? Which is 0, -5/2, and -5/2. This is -5/2 row 2, just as a side. Okay. So let's write that in, plus, and row 1 is 1, 5/2, and -3/2. So when we add that, we get 1, we get 0, and this turns into negative 8 over 2, which happens to be negative 4. So we plug those back in. We've got 1, 0, and negative 4. And again, because we have 1s down that diagonal and 0s everywhere else, we're not worried about this side, just we get whatever we get on this side. This translates to x is negative 4, y is 1, or better, the ordered pair negative 4, 1. All right, I'll see you in the next example.